write out your answer. So this is always going to be your constant. And then work your way backwards. So this is your constant, this is your x, this is your x squared, and this is your x cubed. Then we have our answer as, I'll write it here, x cubed plus, oh, I forgot my coefficients. So this is the coefficient. So 7x cubed minus 6x squared plus 6, and then your constant, oh, back up. I just messed up. Scratch all that. This is not the constant. This is your remainder. I messed up. Sorry about that. So this is your remainder. Remainder, this is your constant. This is your x, and this is your x squared. Woo, I'm very happy I caught myself. So 7x squared minus 6x plus 6, and this is your remainder of 2, and what you're putting the remainder over is this term right here. Sorry about that. So it goes remainder, constant, x, x squared, and if there's more, x cubed, if there's more, x to the fourth, etc. But this is your remainder. Remainder. Sorry about that. Okay, number 16, 17, please go back and watch your Unit 5 test. There are examples of how to graph these. For number 18, it's asking us for all the possible rational roots of a function. So make sure that anytime you see this keyword possible, you're using the rational roots theorem. And that's where you take your last coefficient, your coefficient, which is the last term here, and your leading, let me try again. You take your constant, I'm going to get this right eventually. You take your constant, which is your last term, and your leading coefficient, and you have what we have, m over n. So m is your constant, 2. N is your leading coefficient, which is 2. And you're going to write out the factors of it. So plus or minus 1, what's the factors of 2? Plus or minus 1, plus or minus 2. Factors of 2, plus or minus 1, plus or minus 2. And then you're going to write these out as a fraction. So all denominators are going to be over all of the numerators. So I have two denominators, 1 and 2, and then I have 1 as my numerator, so each numerator has to go on each denominator. So then I have 1 and 2 again, and then I have 2 and 2. Simplify that. So 1 divided by 1 is 1, so I have plus or minus 1, plus or minus 1/2, plus or minus 2, and 2 divided by 2 is 1, and I already have 1, so that's it. So these are all of the possible ones. Then it's saying find all of the rational roots. So different. Possible means rational root theorem. If it says all, then you actually need to find the zeros, find the roots. Which ones actually work? So is it going to be plus 1? Is it going to be minus 1? Is it going to be 1/2? So if you have a calculator, the easiest way to do it, if you don't have a lot of them, is just start plugging it in. Take 1, plug it in. If it gives you, let me back up here. Oh, I skipped a step. I'm like, why did that not make sense? You're going to set this equal to 0. If it does, in fact, equal to 0, because we're trying to find zeros, if it equals to 0, then you have a root. You have a 0. If it doesn't, then you move on to the next one. You have to try all the positives of this, and you have to try all the negatives of this. So let's see. Let's try positive 1. So 2 times 1 cubed is 1, so we have 2. Let's write this down so I don't lose track. So I have 2x cubed minus x squared minus 5x minus 2. We want to see which one's equal to 0. So I'm going to plug in 1. I'm going to check if it's equal to 0. Then I'm going to plug in negative 1. And I'm going to do that for all of them. Now, another way that you can do this is instead of plugging in every single number is Once you find one, you can use synthetic division to find out what your other factors are. And so that way you can see which ones. So let's start with 1. Let's hope 1 or -1 does give us a 0, and then we can continue with synthetic division. So 2 times 1 is 2. 2 minus 1 is 1. 1 minus 5 is -4. -4 minus 2 is not 0. So it's not 1. Let's try -1. 2 times -1 is -2. -2 plus 1 is 1. -1 times -5, that's a +5. I'm adding 5. I'm subtracting 2, and I get 2. So -1 doesn't work. So I'm trying 1/2. I'm actually going to try 2 because I don't want to deal with a fraction, so I'm hoping that maybe 2 will work. Oops, this should be a minus. And then I'm going to try -2. And again, this is positive. Okay, so 2 cubed is 8. 8 times 2 is 16. 16 minus 4 is 12. 12 minus 10 is 2. 2 minus 2 is 0. So this one gives us 0, in fact. So then we know that our root, one of them, is a 2. So then this is what I mean by using synthetic division. Since we know that our root is 2, I'm going to use synthetic division. So I have 2, -1, -5, -2. My root is 2, so I know that 2 works. That's my 0. We don't have to do the opposite of it because this is my root, so we always write roots here. Bring down 2. 2 times 2 is 4. 4. 2 times 2 is 4. 4 plus, this is -3. Just kidding, this is +3. I can do math. 3 times 2 is 6. 6, this is 1. 2 times 2, this is 0. So again, this is the remainder. I learned from my mistakes. This is my constant. This is my x. This is my x squared. So then I have x squared, 2x squared, plus 3x plus 1 as my other factor. And then I can maybe use the diamond. Oh, sorry, guys. I apologize for not having all of that on the screen. So what I did is I used the synthetic division. I found what my other factors are. So then I have x minus 2 as a factor. This is a factor, and I'm going to see if I can factor this further. So 2 times 1 is 2, and I need 3, so I can do 1 and 3. Divide by 2, divide by 2. So I get, what do I get? So this, it actually does in fact factor, because 3 times, we're adding it. This is 2, sorry. 2 plus 1 is 3, 2 times 1 is 2. So this factors to x plus 1. I wonder why -1 didn't work. I must have done my math wrong. And 2x plus 1. That's weird. I have to double check that now. Sorry guys, I get so into doing the problem that I forget to check if you guys can see what's happening. That's my mistake. This is what's perplexing me. One of the factors is 1 and 1. That's my fraction. So I have x plus 1 should give me a 0 of -1. But when I plugged in -1, it didn't give me a 0. So I must have done my math wrong. But so then we have our roots or our zeros as 2, -1, and this is, what is this? 1/2, positive 1/2. So then we have this as our rational roots. These are the actual zeros that work. And then these are all of our possible ones. So possible, use the rational roots theorem to state what are the roots. Use synthetic division, use the rational roots theorem, factor to find what the actual zeros are. All right, you guys, the bell's going to ring here shortly, so I'm going to wrap it up. This is the end of part 2. If I have a moment, I will upload part 3 if I can record it. But definitely take a moment to watch Miss Denny's video. That is the pretest number 2. I have linked it in your Google Classroom. If you have any questions, definitely message me on Reminds. That way I can answer any last minute questions before your final tomorrow. Good luck!